Okay, welcome back again guys sa subject natin, Principles of Steel Design. And for today, we will be solving another example involving block shear rupture. So last time, we already discussed an example involving a grid type connection or yung parallel type yung bolt natin o pare-parehas lang siya ng spaces. Right now, yung kasunod na sa solve natin will be a staggered connection and we will try to solve yung capacity ng section natin based from all of the limit state na napag-aralan natin. Okay? So, this is the problem. An L4 by 3 by 1/4 is bolt connected by 19 mm diameter bolt arranged as shown. Assume A36 steel is used. Determine the design capacity of the angle according to all applicable limit state. Okay? So, as mentioned in the problem, we will design or identify the capacity of our section based from all applicable limit state. And based from our previous discussion, we already know 4 limit states. Okay? Yung una is yung gross section yielding natin, GSY. We have yung net section rupture. Yung pangatlo is yung sa slenderness limitation, but since the problem does not contain a length or hindi specify kung ano yung length ng member, hindi natin sasama sa slenderness limitation. And yung last is yung bago nating na-discuss, which is yung block shear rupture natin. Okay? So, we will try to identify the capacity of our member or this particular section based from these limit states. Okay? So, to start, let us first look at our section. The given section is an L by 4 by 3 by L by 4 by 3 by 1/4. So, in metric scale, ang equivalent niyan, ang L4 by 3 by 1/4 is also equivalent to L100 by 75 by 6.25. Okay? So as you can see, dito sa diagram natin, kita na agad natin na yung one leg natin is 100 and then automatic yung other leg natin is yung 75 na leg natin. Okay? And as you can see, itong thickness natin is given by the value na 6.25, which is the conversion ng 1/4 times 25 mm. So 6.25. Okay? So ito po yung ating values for this problem. Then ano pang given? We have a diameter ng bolt. Given yung diameter ng bolt natin, the given value of diameter ng bolt is 19 mm. Okay? So alam natin ang effective hole diameter natin is diameter of bolt plus 4 mm. So that is 23 mm. Okay? And then we have A36 na steel. So for A36 na steel, we should remember na ang Fy value ng A36 is 248 megapascal. And then we have an Fu value of 400 megapascal. Okay? So automatic na yan once na A36 yung given na value sa atin. Right? Next. So I think that's all the given that we need para makapag-start na tayo mag-solve. Okay? So ang unang solve natin is yung gross section yielding. Okay? So let's have gross section yielding o GSY. So pag hinanap natin yung capacity ng gross section yielding, ano ang formula ng ating RN? RN natin pag gross section yielding is equal to Fy times yung gross area natin. So we need the value of gross area nung section natin. So looking at the table that you have, table 1-7, ano po yung value ng L4 by 3 by 1/4 rather. Ilan guys yung value ng area? Pa-check nga po. L4 by 3 by 1/4. What is the value of area? Anyone? Pa-check ako ng table. 4 by 3 by 1/4. Yung value ng AG natin.
1.69.
Okay, so according to the table, that is 1.69 inches squared. Okay, thank you. So once we have that, we can now determine yung capacity ng section natin based din sa equation ng Rn natin na Fy times Ag. So substitute natin yung Fy, that is 248 Newton per mm squared times yung area gross natin, which is 1.69 inches squared, times, convert natin sa 25 mm per inch, tapos i-squared natin to, and then divide natin yung whole equation natin by 1,000 Newton per kilonewton. So, para mag-cancel out yung units natin, and then yung Newton mag-cancel. So, we will have a value of Rn equals to 248 times 1.69 times 25 squared all over 1,000. That is 261.95 kilonewton. That is yung nominal resistance pa lang, ano? Ibig sabihin, hindi pa natin ina-applyan ng design philosophy. Ngayon, kapag LRFT pinag-uusapan natin, okay, that is VRN. So, ang fee natin for LRFT para sa GSY, that is 0.9 nung RN natin. So, in our case, 0.9 times 261.95 kilonewton. So, ang VRN natin will be equals to, times mo lang ng 0.9, that is 235.755 kilonewton. Okay? Then for ASD, that is Rn divided by omega. So that is 261.95 kilonewton. And ano po ang omega natin for yielding? Anong gagamitin natin safety factor? For yielding, that is how much? That is
1 po ba siya?
yung divide natin siya na factor by 1.67. Okay? So, para sa gross section yielding, 1.67 yun. So, 261.95 divided by 1.67, that is equivalent to 156.856 kilonewton. Okay? So, ito yung ating nominal capacity, and then ito yung sagot kapag may specific design philosophy na hinahanap. Ito yung para sa LRFD, ito yung para sa ASD. Hindi mo po, again, you cannot compare LRFD value with ASD value because they are of different design philosophy. So, pwedeng titingnan na lang natin, muna natin is yung nominal resistance. And then once na sinabi na LRFD yung requirement or ASD yung requirement, that's the time that you will use yung VRN or Rn over omega as your answer. Okay? So, this is our value for GSY. So, question or verification with the first limit state natin. So, okay na tayo dito sa gross section yielding. So, the same lang naman to nung ginagawa natin before, no? Walang bago dyan. Same pa din yung procedure niyan. Alright? Sige. So, let's continue with net section rupture. Okay. So, for net section rupture, NSR, ang formula ng Rn natin is equal sa Fu times AE. And we know na si Fu, si AE, magiging siyang U times AN. So, we need net area. Pero, since ang section natin is an L shape or an angle, tapos staggered yung connection niya, ano yung ginagawa nating procedure para mas ma-analyze natin ng mas madali yung plate natin o yung mismong L shape natin? Anong ginagawa natin sa kanya? Ina-idealize natin as what?
Isang whole plate po.
Ano? Yan, kino-convert natin as a whole plate, ano? And to do that, we take off or we chop yung portion nung leg. So, i-retain natin to. And then itong chop portion na to, i-vertical natin to make it as one plate. So, idealization lang again ito, no? So, again, we are doing that para pag connect na natin yung value ng staggered factor, we will not have a problem with the thickness dun sa curvature or dun sa mismong dito, no, sa part na to, pa nag-staggered factor na tayo. Okay? So, let's convert first our L shape. So, yung L shape natin, yung kanyang isang leg is consistent yan na this is 100. Okay? And then, what will be the value of the upper side? Okay? So, kung dito, okay, tingnan natin dito. Ito yun, ano? dito, kinat natin to. So, ito yung makukuha nating section. So, ilan ngayon yung distance nito? That is, yung 75 natin, ma-minus natin ang thickness natin na 6.25 para makuha natin yung distance na yun, o yung length na yun. Ano? So, that is 75 minus 6.25. That is 68.75. Okay? So, this is 68.75. Okay? So, wait lang ha. Fix lang natin tong. Yun o. Okay? So, dito, meron tayong bolt sa taas. Then, meron din tayong bolt sa baba. So, yung arrangement niya is like this. And then, ito yung brake line natin. And then, we have a distance for this part and also a distance for this portion. Okay? So, tingnan natin. Yung una, itong portion na to, okay, yung distance niyan is the same as itong portion na to, which is 62.5. Okay? So, 62.5. Okay? And then, itong taas na portion natin, this is actually the distance from dito sa edge papunta dito sa plate na to. So, sa hole na yun. Okay? So, that is 43.75. Ima-minus natin yung thickness natin na 6.25. So, 43.75 minus 6.25, that is equivalent to 37.5. 37.5. Okay? So, in total, pag kinuha natin yung kanyang gauge, that is equivalent to 100. Okay? And then, let's complete this one. So, dito, sa taas na portion, so that is equivalent dito sa portion na nandito. So, that is just 31.25. Okay? 31.25. And then yung sa bottom part, this one, that is equivalent dito sa portion natin nandito, which is 37.5. Okay? So, 37.5. Okay? So, ito yung assumed plate natin, ayun yung loading natin. So, for net section, for net area natin, kailangan identify natin yung critical path natin. Okay? Kompletuhin lang natin tong diagram natin. Yung spaces natin, we have 37.5 mula sa edge, ano? Tapos typical daw siya. So, ibig sabihin, itong distance ng bolt natin is 75. This is also 75. So, ibig sabihin, ito, papunta dito sa dulo, that is 75. Okay? So, rewrite ko lang yan dito. So, itong portion na to, these are all 75. Okay? This one, okay? So, 37.5, 75, then to ay 37.5. Okay? So, yan. So, yan yung diagram natin for our converted na plate natin, ideas plate natin. Alright? So, next is identify natin yung critical path natin. Critical path natin. So, for our critical path, ginagawa ulit natin. Imagine natin, nandito yung position natin. Then, we have our flashlight. Then, yan. So, ang may illuminate niya is, ito, no, yung unang dalawa. So, ito yung magiging critical bolts natin, yung first line ng bolts natin. Yan, yung dalawang yan. Okay? So, lagyan natin ng pangalan ngayon, yung, sorry. Okay? So, let's have naming system dito. So, let's call this as A, B, C, D, E, tsaka F. So, for our critical path, Ano yung mga critical path natin according to our diagram? Guys, what is our critical path? Can you identify one critical path?
BCDF.
B, C, D, F. Okay, so that's one. Alin pa?
ADF.
Yung
ADF po.
DF natin. Okay? So, ADF. So, alin pa? Meron pa ba tayong pwede pang gawin o gamitin? So, again, as I mentioned before, we can check or verify again yung other. Bawa si BDE. BCDE. Pero again, it will not govern. Kasi nga, mas pumdadiretso yung ating mismong uh, failure dun sa position kung saan mas malapit siya. Okay? Hindi siya magko-cross ng o mag-stagger nang wala siyang butas doon, ano? So, for this case, ito yung dalawang path na pwede natin i-look into to get yung critical net area natin. Okay? So, next. Kunin na natin yung net area. So, net area muna tayo. AN. So, start tayo with path BCDF. Okay? So, si BCDF, ang itsura niya is syempre ito. Itong path na to. Tapos yan. Okay? So, for path BCDF, that is AN is equals to AG natin. AG natin is 1.69. So, 1.69 times 25 squared minus ilang volt yung dadaanan natin?
Dalawa.
We have 2 volts. And then, ang effective diameter natin is 23 times 6.25. And then, meron tayong stagger. So, meron tayong isang stagger na ang spacing is 37.5 and then ang gauge ay 100. So, we have 37.5 squared, 6.25 divided by 4 times 100. Okay? So, let's calculate that. Okay, so 1.69 times 25 squared minus 2 times 23 times 6.25 plus 37.5 squared, 6.25 over 4 times 100. Our value is 790.723 mm squared. Okay, so this is our net area for path BCDF. Okay, next, let's have yung next path natin, path ADF. Okay, so path ADF is, lagyan natin ng other color. ADF is this one. So, itong diretso na to, ano? Yan. So, ADF is just a straight path. So, 1.69 times 25 squared minus ilang volt yung dadaanan? We have yung volt D lang, no? So, 1 volt, 23 times 6.25 plus staggered factor. Wala tayong staggered factor, so that will be 0. So, AN is equals to 1.69 times 25 squared minus 23 times 6.25. That is 912.5 mm squared. Okay? And then, malalaman natin yung mas critical sa kanya, whichever is smaller. So, for this case, ang smaller net area is yung path BCDF natin. Okay? So, yun yung gagamitin natin for AN. So, para doon sa formula, okay na tayo ng AN. Now, kailangan natin ng value ng U. Okay? So, shear lag factor tayo. So, ano magiging value ng shear lag factor natin?
1.0 po.
1.0. Kasi both or all parts of our member are connected or may bolts. So, we satisfy yung case number 1, which is equals to 1.0. Okay? So, okay na din pala tayo dito sa staggered factor natin. So, shear lag factor rather. Okay? So, pwede natin makuha yung capacity. So, Rn is equals to Fu U times An. Substitute natin, we have 400 times 1.0 times 790.723. Then divide natin by 1,000. Makukuha natin yung Rn natin, which is 400 as 1.0 times 790.723. Divide 1,000. That is 316.289 289 kilonewton. Okay, that is our nominal resistance. And for our LRFD, so we have VRN, that is net section tayo, so times 0.75 natin, that is equivalent to 237.217 kilonewton. For ASD, we have Rn over omega. So, di-divide naman natin ng 2. So, 316.289 divide 2. That is 158.145 kilonewton. Okay? So, this is our capacity for NSY. And then, this is our values for LRFD and ASD kapag that section rupture yung pinag-uusapan natin. Okay? So, that's our values. So, ibig sabihin, we are now down also with our second limit state. Okay? So, kung halimbawa yung dalawa lang yung gagamitan, o doon lang natin ipag-compare between GSY and NSR, makikita natin na value ng GSY is much lesser than the value of NSR. So, kung yung dalawa lang ang pag-uusapan, si GSY yung pwede natin sabihin nag-govern na resistance natin. Pero, we still have another limit state, which is yung black shear rupture na we need to check out. Okay? So, punta natin yung pangatlong condition natin. So, ngayon para sa black shear rupture, ano yung kailangan natin i-identify para makapag-start tayo kay black shear rupture? Guys, ano yung kailangan natin i-identify? Kailangan kunin natin yung black shear path na pwede natin consider for our solution. Ano? So, this is our converted plate. Sa tingin nyo, ilang path yung pwede siya mag-fail in black shear? Mga ilang failure kaya siya? So, sige, identify natin. Yung una is, katulad nung ginawa natin before, pwedeng yung parang ito, portion na to, and then ito, then dito siya. Yan yung ating first failure path. Okay? Next failure path is same yung ating shear plane sa taas. Same to tension plane natin, pero dadiretso yung tension plane natin dito. That is path number 2. Okay? And then last path natin is dito naman siya sa ilalim. And then dito tayo. And then tataas naman siya dito. That is our third shear path, black shear path. Okay? So, kailangan i-identify natin or i-calculate yung capacity ng each path before we can conclude which path will govern dun sa black shear rupture natin. Okay? So, let's start off with path number 1. Path number 1. Okay? So, for path number 1, ito is i-minimize lang natin ng konti. Okay? So, we have here path number 1. So, showing this one dito. So, we have our plate, our bolts, then path number 1 natin is pag ganito. Okay? So, our goal is to identify yung AGV natin. And AGV, ilan ang ating shear plane dito? Ito yung direction ng our loading. Ilan ang ating shear plane? Ilan ang shear plane natin, guys? Ang shear again is yung parallel dun sa loading natin. So, we have two shear plane. Ano? We have this shear plane, tawag mo SP1, meron tayong shear plane number 2. Okay? And then we also have our tension plane dito sa kabila. Okay? So, ayan. So, to solve for the gross, yung sa shear ng area natin, we can identify yung shear plane individually o paghiwalay natin. Halimbawa, lagay ko dito, meron tayong shear plane 1 plus shear plane 2. So, yung una, sa shear plane 1, ito yun, identify natin yung width niya and then multiply natin ang thickness. Shear plane 2, identify natin yung width, then tsaka natin multiply ng thickness para makuha natin yung total gross shear plane natin. Okay? So, para sa SP1, ano yung magiging width natin? Ilan to? Itong value na to. Okay? So, this is 75. This is 37.5. This is 75 tsaka 75. Okay? So, ilan yung width natin for SP1? That will be 75 plus 75. So, that is 150. So, 150 times yung thickness natin, which is 6.25. Plus, for SP2 is this width. Okay? So, that is 37.5 plus 150. That is 187.5 times 6.25. Okay? So, calculating the value. So, we have 150 times 6.25 plus 187.5 times 6.25. That is our value, 2,109.375 mm squared. Okay? So, may another form pa to, no? Itong mismong, ano natin, pwedeng gawin mo is kunin mo na yung total width muna. Okay? So, ang pwedeng isang solution, ibahin natin yung kulay, ano? Bawa, kunin mo muna yung length, that is 150 plus 187.5. Tapos, tsaka mo multiply ng thickness na 6.25. That will also yield the same result as itong nasa ilalim natin. Kasi makikita nyo parang finactor out lang natin yung 6.25. Pero again, it's up to you kung saan kayo mas madadalian or mas sigurado yung pag-calculate ng value. Kasi ang mas gusto natin, mas makuha yung tamang value kaysa malito kayo doon sa pag-create ng ganitong form. Ano? Okay? So, that is, ayan. Ayan. Okay? Next, we have yung A and V natin. For A and V, pa-minus natin yung volts natin. So, ang bawa, pag-separate muna ulit natin si SP1 at SP2. For SP1, we have 150 times 6.25. Tapos, ilan ang ma-minus natin butas para dito sa first na shear plane natin? Ilang butas yun?
2 po.
Again, iba yun ay dito, no? Itong dito, hanggang center lang tayo ng bolt.
1.5 po.
No, it should be 1.5 lang. Okay? So, 1.5 lang. Okay? So, we have 1.5 times yung 23 times 6.25. So, this is yung net natin for shear plane 1 pa lang yan. Okay? Plus, yung para sa shear plane 2, we have 187.5 times 6.25 minus, ilan naman ngayon? So, dito we have 1,
0.5 po.
2.5. Ano? So, magiging 2.5 naman siya times 23 times 6.25. Okay? So, that is our A and B. Okay? Again, lagyan natin ng or, no? Pwede nyo mapasimplify yan. Ang gagawin nyo, kunin nyo na lang itong nakuha nating gross, kasi ito din yun, ano, pag pinag-plus. So, that is 2109.375 minus yung total nung bolt, which is 1.5 tsaka 2.5 for 23 times 6.25. Parehas lang din ang magiging answer yan. Okay? Pero again, both form are accepted as long as naintindihan nyo kung which one yung gagamitin nyo. Okay? So we have 1534.375 mm squared. Okay, so that is our AGV and ANV. Okay, next. After this one, we need yung AGT naman natin. Okay, so dito ko na nalagay sa side, AGT. So for AGT, so tension plane na tayo. Ang tension plane natin, itong naka-slant natin. Di ba pag naka-stagger tayo, anong ginagawa natin gross na width o na area ng section natin? Nung pa nagbabalikan natin yung gross section yielding natin, tsaka yung net section rupture. Alin ang gross natin? Anong area? Para maging gross siya. Di ba, kino-consider natin is yung perpendicular na distance, ano? Yung perpendicular na distance. Ito yung laging gross natin. Okay? So dito, ito yung naka-stagger natin. So dapat, kukunin natin yung perpendicular na width, which is yung gauge natin dito na 100. Okay? So, lagay natin dito. Ito yung 100. So, which is magiging 100 times 6.25. So that is 625 mm squared. Okay? So ngayon, yung pagkuha naman nung ANT, okay, ibaba ko lang to para ma-explain ko ng maayos sa ito. Okay? So, halimbawa ito yung staggered nating bolt. So meron siyang center dito. Yung kanyang gauge is 100. Yung kanyang spacing is 37.5. Okay? Ngayon, para sa ANT, kailangan i-minus natin yung butas dun sa stagger natin, ano? So, dito, ang butas natin, di ba dito sa circle natin, okay? Itong radius natin na to ay kalahati. Okay? And dito, meron pa tayong kalahati ulit. Okay? And then, alam natin ang radius kapag itong measurement na to, same lang yan ang value. Kasi radius nga, ano? Anywhere do sa circle, parehas lang yan ang value. So, kung meron tayong stagger dito, okay? Yung stagger natin is itong portion na to. Okay? So, consider natin, ito yun, meron tayong 0.5 na butas, then meron tayong 0.5 na butas. So, ibig sabihin, meron tayo, all in all, ilan ang ibabawas natin? 1.0. So 625 minus 1.0 times 23 times. Tapos, we have 6.25. Okay? And then plus, yung staggered factor natin, 37.5 squared times 6.25 over 4 times 100. Okay? So, ANT is equals to 625 minus 1 times 23 times 6.25 minus 37.5 squared, 6.25, 4 times 100. Okay? So, we have a net area of how much? 459.277 mm squared. Okay? So, ayan yung apat na kailangan nating value ng areas para makakalculate natin yung capacity nung part 1 natin. Okay? And then, going back dun sa ating solution, ayusin ko lang to. Okay? So, formula natin again is Rn is equals to UBS FU ANT plus 0.6 minimum between nung FY AGV tsaka FU ANV. Okay? So, substitute natin UBS. So, since this is an angle, hindi siya cope beam with multiple rows, this is 1.0 times FU is 400. ANT natin is ito. So, 459.277 plus 0.6 minimum between FY natin is 248. 248 times AGV natin. that is 2109.375. Okay, then we have 400 times 1534.375. Okay, so check natin yung value nito. Pag pinag-multiply, 248 times 2109.375, the value is 523,125, 400, 1534.375, that is 613,750. So ito yung mag-govern sa kanya. So pag pinindot mo sa calcu, ito, pipindot mo plus 0.6 times itong value na to. Okay? So, pindutin natin 1 times 400 times, rewrite na lang natin para di kayo malito. So, is equals to 1.0, 400, 459.277 plus 0.6 times 523,125, and then divide it by 1,000 para maging kilonewton. So we have Rn is equals to 459.277, 0.6, 523,125, divide 1,000. We have 497.586 kilonewton. Okay? So this is our capacity for part 1. Okay? Then for LRFD, okay? Ang ginagamit natin for LRFD, same tayo ng rupture, that is 0.75. And then, ang sa omega is 2.0. So, ang PRN natin is times 0.75, that is 373.189 kilonewton. And then we have for ASD, Rn over omega, that is 497.586 divided 2, that is 248.793 kilonewton. Okay? So, yan yung capacity natin for part 1. Okay? That is for part 1 pa lang. Okay? Sige, let's continue. Duplicate ko lang tong ano natin. Okay, so let's have the second path. Okay, so path 2 tayo. So erasing ko lang to kasi I already duplicated this page. So yeah, erasing natin to. Okay, so for path 2, may path 2, we have our plate. Ito yung ating connection. Ang mangyayari ngayon, ito yung ating shear plane sa taas, our tension plane, and then magdadiretso siya pababa. Ganyan yung nag-iitsura sa path 2 natin. Okay? So, magbabago yung ating shear plane kasi naging isa na lang siya, yung SP1 lang, yung consider natin sa equation natin. And then, para dun sa ating tension plane, bukod sa ito lang yung distance na kanina, nadagdagan siya ng pababa na distance. Okay? So, pag-calculate natin yung AGB, that will be equals dun sa shear SP1 natin, that is 150 times 6.25. That is 937.5 mm squared. And then, for A and V, ilang butas yung tatanggalin natin? We have 1.5. Okay? So, 937.5 minus 1.5 times 23 times 6.25. Okay? So, minus 1.5, 23, 6.25. That is 721.875 mm squared. Okay? Then, for AGT, ano naman yung AGT natin? Kanina, 100 lang ginamit natin. ito lang, portion na to kasi yun lang yung tension plane natin. Ngayong tension plane natin is bumaba pa dito, ilan ngayon yung magiging value ng ating AGT? Ano yung width natin? So that will be 100 plus yung portion na nandito sa baba, which is from our diagram earlier, that is equals to 37.5. Double check na lang natin ha. 37.5 nga. Yes, 37.5 nga. Okay? 37.5. So, we have here 137.5 times 6.25. So, 137.5 times 6.25, that is equals to 859.375 mm squared. And ang ANT natin, ilan ngayon yung butas na aalisin natin? Yung minus natin. What do you think, guys? Ilang butas? So ngayon, dito, balikan natin. Ito, meron tayong 0.5. Meron tayong 0.5 dito. That is 1 already. Tapos bababa pa tayo. Okay? So that will be 1.5. Okay? So 1 whole dito. Tapos kalahati dito kasi dadiretso tayo dito sa edge ng plate dito sa baba. Okay? So that is 1.5. So now we have 859.375 minus 1.5, 23, 6.25 plus yung ating stagger, 3.75 squared times 6.25 over 4 times 100. Okay, so ANT, so minus 1.5, 23, 6.25 plus 3.75 squared, 6.25 over 4 times 100. That is 643.97 mm squared. Okay? Yan. So, kompleto na ulit yung tatlo. Punta na agad tayo dun sa formula ng Rn. Okay? So, substitute ko na diretso, 1.0 times 400 times ANT natin is 643.97 plus 0.6 minimum between yung 248 multiplied by 937.5 tsaka yung 400 multiplied by 721.875. Okay? So, ito, lagay natin kung ano yung equivalent value. 248 times 937.5, we have 232,500. Ito, 400 times 721.875, we have 288,750. Okay? So, ito yung mag-govern na value. So, we have Rn is equals to 1.0 times 400, 643.97 plus 0.6 times 232,500. Okay? And then, divide natin by 1,000 para maging kilonewton. So, Rn is equals to 1,400, 643.97 plus 0.6, 232,500. And divide 1,000, we have 397.088 kilonewton. Okay? So, yan. Ito yung ating Rn. And for LRFD, again, we have VRN is equals to times natin ng 0.75. That is 297.816 kilonewton. For ASD, we have Rn over omega. So, 397.088 divide 2. So, 189.544 kilonewton. Okay? So, that is for part 2. Okay? Question po so far kaya? Or would like to clarify while I'm checking my calculation?
Wala naman po, sir.
Okay? So,
Wala.
So, path 2 pa lang yan. So, we still have another path. So, sige, tuloy na natin. So, okay. So, ito, i-delete ko lang ulit. Okay, so, dito is, we have path 3. So, for path 3, we have this connection, and then this is our bolts, and then ang ating critical ay dito. Okay? So, yan. Yan yung loading natin. So, for AGV ngayon, mangyayari, ito yung shear plane natin. So, yung kabila naman, yung SP2 naman yung gagamitin natin. And then, for our AGT, magbabago yung value. Imbis na 137.5, gagamitin natin is yung 31. Ngayon, 31 point something. Yung 31.25 na distance, ano? Ayan, yung 31.25 na distance. So, lagay lang natin yun doon sa dito. So, 31.25. Okay? So, let's calculate yung AGV. AGV is yung 187.5 times yung 6.25 natin. So, 187.5, 6.25. We have 1171.875 mm squared. We have A and V. So, we have yung 1171.875 minus yung 2.5 natin na volts. 23, 6.25. We have 2.5, 23, 6.25. So we have 812.5 mm squared. Okay? For AGT, again, ito na yung magiging 100 plus yung 31.25 sa taas. Okay? So we have 131.25 times 6.25. That is 820.3125 mm squared. And for A and T, that is the same, ano? Magiging butas natin is baliktad.
1.5.
So dito naman 0.5, 0.5, then another 0.5. So 1.5 tayo. Okay? So we have 820.3125 minus 1.5, 23, 6.25 plus 37.5 squared times 6.25 over 4 times 100. Okay, so A and T is equals to 1.5, 23, 6.25 plus 37.5 squared, 6.25 over 400. Okay, so that is 626.66 mm squared. Okay, so ayan, kompleto na ulit yung areas natin. So we can now calculate yung Rn ulit natin. So Rn is equals to 1.0 times 400 times yung 626.66 natin plus 0.6 minimum between yung 248 times yung AGV natin na 1171.875 tsaka 400 times 812.5. Okay, so check muna natin ulit to. 248 times 1171.875, that is 290.625, and 400 times 812.5, that is 32500. Okay, so ang governing natin is this one. So simplify natin. O nawala. Okay, so Rn is equals to 1.0, 400 times 626.66 plus 0.6 times 290,625. Then divide natin by 1,000 to make it kilonewton. Rn. So 400, 626.66 plus 0.6, 290,625 divide 1,000. we have 425.039. Okay, that is in kilonewton. Okay, then for our LRFD, so VRN, so multiply by 0.75, that is 318.78. And then for ASD, we have Rn over omega, divide lang natin ng 2, that is 212.520 kilonewton. Okay, so that is our capacities. Okay, so sulat natin dito ngayon sa BSR summary natin. So yung part 1, okay, Rn natin is how much? 497.586. Sorry. 497.586 kilonewton. Okay. Part 2, Rn natin is 397.088. Okay. For part 3, we have Rn is equals to 425.039 kilonewton. Okay? So between the 3 paths, alin ngayon yung mag-govern na path natin? Of course, the path with the smallest value ng resistance, okay? Which is yung path number 2. So ito yung mag-govern natin na path. So ito yung pinaka-capacity natin for black shear rupture. Okay? And then, once kinumpare natin, so let's have dito yung summary ng lahat ng ating capacity for each limit state. So yung una, so we have for cross-section yielding, our capacity again is how much? We calculated 261.95. Okay? So 261.95 kilonewton. For net section rupture, we have capacity equal to 316.289 kilonewton. And then for black shear rupture, we have Rn is equals to, calculate natin yung nag-govern, 397.0888 kilonewton. Okay? So, comparing this value, alin na mag-govern natin na limit state? So, of course, limit state with the smallest capacity, which is itong 261 natin. Okay? So, pag tinanong, ano yung ating governing Rn, ang answer pala natin is yung 261.95 kilonewton, which is due to gross section yielding. Okay? So, ibig sabihin, yung kauna-unahan pa lang natin na-calculate na Rn, yun yung answer sa atin. Pero, we will not be so sure of that if hindi natin sinolve yung net section rupture tsaka yung black shear rupture natin. Okay? And so that's how you solve for the capacities of all limit state available dun sa tension member natin. And this type of solving or solution will be required dun sa examination natin next week. Okay? Question po before we end? Okay. Okay. So if none, again, let's have a quick recap lang. So we have a given L-shaped angle bar. So we identified yung 3 applicable limit state, which are gross section yielding, net section rupture, and black shear rupture. We first calculated for the gross section yielding, and then we had a capacity of 261.95 kilonewton, and then we calculated net section rupture and arrived with a capacity of 316.289. And then lastly, we have for black shear rupture, we identified 3 black shear rupture path, and then based from those path, ang nag-govern ay yung second one, which is 397.088, And then we compared all of the limit states, and then we arrived with an answer na 261.95 kilonewton as the gross section yielding capacity governing for our problem. All right? Okay. So, ayan. So that ends this lecture for today. Thank you for attending po.